Okay. Thank you. Okay, so the point I need to emphasize about the OpenSSL is what now?
So this is just the regular version. We've not made any code changes to it to make it amenable for fuzz testing. Because one of the pain points people are going to be wary of is, if I want to do this, I'm going to have to do custom development on my source code base, which you do not have to do with fuzz testing.
Okay.
So they could go download this exact version from the internet and reproduce our results very easily.
Okay.
So really there's going to be two steps in adding coverage guide fuzz testing to the project. The first one is that we have to tell the fuzzer how we want to run and fuzz the application. Because the fuzzer is unique to our app and it's going to find business logic issues unique to our app, we have to give it that extra context. And to do that, we're going to build what's called a Fuzz Target. And that's in this handshake fuzzer CC file. Let's go ahead and open this one up. So a lot of this file is boilerplate that would be very familiar to an OpenSSL developer. Essentially what we're doing here is we're setting up the tests to be able to run successfully. The way that we interface with the fuzzer is we implement this one function, this LOVM fuzzer test one input function. And what this is doing, the fuzz engine is going to call this over and over and provide random data every single time it calls it that's going to be different each time. And that's what this data field is. And then it gives us the length of that field. In this specific fuzz test, we have to set up our environment. And this is standard OpenSSL boilerplate. This would be very common to an OpenSSL developer, or you could even copy it from one of your unit tests. The function we actually want to test, though, is this bio_write function. So all we have to do there is, rather than provide it a piece of mock data, we just provide it the random data that the fuzzer is generating. And it's just going to call this over and over and over again. And that's all we have to do. We also do some cleanup at the end, which again is OpenSSL boilerplate. Any questions on that one before we go to the next piece?
Nope.
Okay. The second part is, now that we've written our fuzz target, we have to tell GitLab to run it as part of our pipeline on every build. So for this, we'll go to the CI YAML file and we're going to do two things.
Hold on.
The first one is
hold on. I had a question about that. So we can't set that up in Auto DevOps, or in the, we've now got that like assisted setup?
Not yet, no.
Okay.
It's something we're talking about, but nothing today for that.
So you have to go into the CI YAML.
Yeah. So we're going to first include a coverage fuzzing template. This is just going to define all the backend pieces that the job needs to run. And then we're going to define our actual fuzz testing job, in this case called Heartbleed Target. And what we have to do here is we have to actually build that piece of fuzz target code that we just wrote. And that's what all of these lines are doing. This is all pretty generic to OpenSSL, and it's going to be different for every single application. But essentially what we're doing here is we're taking that fuzz target code we had, we're building it in such a way that it can call the various functions that we want to test. And then the final line of every fuzz target is going to be this one on line 25, where we call GitLab cov fuzz. And that's the actual fuzzer. And we're just going to say run, and then give it the name of that fuzz target we wrote, that handshake fuzzer binary. And that's all we have to do.
Okay.
So once we've done that, we'll make a commit, run a pipeline, and let's take a look at the results that we'll get. So in this case, you can see I've run my unit test as part of my normal testing. The fuzzer Heartbleed target ran. And so we notice that it found something. So if we go to the security tab, we can see that I found one vulnerability, this heap buffer overflow read. And so we're given a bunch of different information here about the crash address of where it crashed in our target binary, the type. We're also given some information about the function names that were in the stack trace where the crash occurred, as well as the actual full stack trace here. And this is the really detailed information from the job log. that a developer would use to figure out where exactly the crash occurred. If we scroll down here, and this is the part you'll want to highlight in the demo, is this TLS1 process heartbeat item. This is where the actual crash occurred in the code, and this is where the heartbleed vulnerability gets its name from. Because it's a vulnerability in that heartbeat function, they called it heartbleed. And so you can see that in this crash state here, as well as all the detailed information. From there, you can create issues, you can discuss with your security team, dismiss them, the standard shift left things that we talk about.
So what part's missing? Because you've got the widget, so you just don't have it in the MR pipeline?
Yeah, so where's an MR we could look at? Because basically, you know how when you have an MR, it'll say like security results and expand. The fuzz results are not put there. So
So you
like
have to
when
go
we
to
did the expand, it won't show them up.
Okay, so you just have to go to that security tab.
Yeah.
Kind of.
One question you'll probably get is someone will say, the stack trace is great, but I need more information than this, like the inputs that caused it. Those are all available in the job itself as artifacts. There's a lot more info in the job log, but if you go into the browse option on the job artifacts area.
How did you get to that?
So we're on the pipeline here. If we just click on the job name, it'll be on the job artifacts on the right here. And so we'll just browse through them. This is going to have all the really low-level information that a developer might want. The corpus here, these are all the test cases that the fuzzer tried, and these are going to be what they can use to reproduce the crash locally. No, I'm sorry, I told you the wrong thing. The crashes directory is the directory they will use to reproduce the crash locally if they want.
Okay.
So I wouldn't highlight this on the demo, but you will likely get a question about this, and that's where that info is.
Okay. Couple questions. What if I just skipped the how to set it up and went straight to showing the results? Because to me, that's the most impactful part.
Yeah, that's an option. I think it'll really come down to timing, like which parts you want to really focus on. Because I agree. I think this is really we found this with very minimal configuration.
Exactly. Because the other stuff is a little bit in the weeds, I'm afraid, because what I want to show is we're making fuzz testing simple and bringing it to the everyday user.
Right.
And I feel like the setup part counters that message.
Yeah. Well, so that's the thing. Because we have to emphasize to people that fuzz testing is easy to get started with, because that's where classical fuzzers fail, right? I feel like if you only show the results, people will be like, yeah, but you probably had to spend a week setting it up, right? So the intent with the early part of the demo is to say, this is really simple. I walked you through it in a few minutes versus a week. But that said, there probably is a way to go through it more quickly. Maybe what you could do is just briefly go through, there's only 2 steps to doing this. You have to provide a fuzz target, which is just how to run your application in the fuzzer, and then add it to your CI YAML file, and then move on from there.
Yeah, I think that would work.
Yeah. Yeah, I think that would probably get the point across.
Okay, and then on the slide deck, do you have that deck handy?
Yeah, this one.
The part with the orange boxes, you did that on commit, didn't you?
I did, yeah.
Can you just quickly walk through how you talked about that? Because,
Sure.
well, just as a refresher.
Yeah. So in this example, we want to talk about a conceptual or a hypothetical application. Let's say that it takes a JSON document as an input, processes it, and does some sort of service like producing a report. So as an example, you might provide a JSON document that is requesting a balance for customer number 5, and you're giving it some sort of auth token that's unique to you when you're logged in. The app processes it, you get it successfully, and you can do whatever you want with the report. Because you're doing good testing, your application would reject erroneous cases like when you ask for an AAA type of request. These are the type of random things that the fuzzer will try as part of providing those random inputs to your app.
And that's just
So the fuzzer,
checking that you did like input validation, right?
exactly.
Okay.
Because the thing we want to highlight here on this slide is the AAA is something the fuzzer might have tried, but because the app was well written and has tests, it returns this error case as expected.
Okay.
Another example, maybe the fuzzer tries to provide an invalid customer ID, and again, we have error checking in place, so it doesn't matter. But let's say the fuzzer finds one case where it provides a valid customer ID, but doesn't change the auth token, and your app just returns a report as expected. That's a major security issue because the auth token I provided, the fuzzer provided, was unique to customer 5, but it got the results for customer 1. So even in an app that has QA and testing in place, the fuzzer found an edge case that wasn't covered previously.
Okay. All right. So that all makes sense. I may add a slide in there for Peach and Fuzz it. I took that out. I might add it back in.
I thought you had one of the acquisition slides, you mean? I thought we had one in here.
Yeah,
right?
it was in there and I took it out, but I think I'm going to put it back in.
Got it. Just a note, when I've gone through both this slide and this slide, these have been time sinks that take a little bit longer than I expected. So really? I would recommend either running just this or the demo.
Not both.
For whatever type, yeah.
Well, tell me how you talk about that one and the 18. If those are, what gets you, what takes up so much time?
So in this one, the thing that takes the time is you have to set the stage kind of for like, what even is this function? Why are we looking at it? And we have to talk through where we have this parse complex function that takes an input. We can see in the logic, though, there's an off by 1 error because it's checking for 7 letters here, but it's only looking at a length of a 6 string. The fuzzer is what would generate that sort of random data and eventually find that test case. And that pretty much is the whole presentation of this slide is redundant when you also show a full demo of the fuzzer. So, because I did a dry run for the cab with both this slide and then going into the Heartbleed demo, and it was a lot of time and a lot of saying the same thing.
Okay.
If that makes sense. That said, if you don't do an API fuzzing demo, I think this one's actually really good.
Okay, so how do you talk through that one?
So in this one, I don't know if there's animations. I might cut out the other 3 just so they're not visually distracting when you first see this. And then do like a click through animation of it. But essentially what we've got is a recording of a request to a web application of some sort. If we look in the top left, we can see the API definition. It's defining an API endpoint at the root on line 19 that takes a GET request, takes a variety of parameters such as the name, which is on line 30. And when we provide a valid request, such as the one pictured on the bottom left, where we're saying the user is DD, first Mike, last Smith, password hello, we'll get a, when we provide this valid sort of request, we'll get a valid sort of response. But what we're going to do is give this to the API fuzzer, and it will say, okay, this is a known good type of request. I'm going to take this and I'm going to mutate it. So in the top right here, we can see the fuzzer changed the username from DD to %27. And then when we give that to our application, it responds very differently. And in this case, on the bottom right, it actually crashes the server with an internal server error. So this is an example of how the API fuzzer takes known good ways of interacting with the app, either through an open API file or a recording of traffic, and can mutate them to find those sorts of edge cases we're looking for.
Okay. Cool.
Yeah, so I like this slide a lot from a conceptual standpoint. I think it's busy though, so I mean, if you like did the one at a time kind of thing, I think it might be easier to follow.
Yeah, I agree. And so can you show me where on the security tab the API results are?
Yeah, so let me pull this one up. I find what my autocomplete wants to show. So this is the repo I added you onto. So let's go to pipelines.
It looks very different from anything else I've seen, so I was not sure where to go.
This is actually a cool GitLab feature. This is our open API rendering. Like this is all driven off of a JSON document. There's no like custom markup or anything.
Oh, wow, that's pretty cool.
So we're looking at this file, just a JSON document, and GitLab auto pretties it up. It's really cool.
That's neat.
So let's go look at a pipeline. This one seems good. So the API fuzz testing is actually under our test tab for right now. Oops. So we're actively working on pulling this into the security tab. The reason we did it this way is because Peach from the acquisition already had JSON output, and this is rendered directly from that. So there was no, or JUnit output, excuse me. So there was no net new development for us to get it in this form. So now we're working on the dev work to put it in security.
Got it.
So each of the fuzzing runs will report an API fuzzer job, a duration. Notably, it found 6 things under the errors column. Mm-hmm. So if we click on that, it'll give us detailed info on each of them. So it'll tell you the high-level name of what it found. In this case, it was a fuzzing injection on this API endpoint. And then it gives you a lot of information about what it found, what it means, as well as a detailed description. So like you can look up the CWE and the OWASP. It has a human readable, like just telling you what things are. So this is actually really cool. The part you want to highlight though, actually, I don't like this one. So I would scroll to, is this the second or the third one?
So this is all 6 of them appended together?
Sorry?
This is all 6 of them appended together?
Correct. Yeah, I would look at the third one in the list because the others require you to dig a little bit too deep for a demo for it to click with people. But what's going to really jump at people is this mutator part, where the fuzzer saw, oh, you tried value 2. I'm just going to try 65,576 and see what happens. And in this case, we had an internal server error. And so then it's going to give you all the original stuff that it recorded, what it received when it, got that back, as well as a bunch of other information that the devs could go ahead and, figure out what went wrong.
Mm-hmm. Okay.
Yeah.
Very cool. Yeah, I can show that. Okay. But this does a good setup of what it is they're going to see, if I can keep it real crisp and short.
Yeah, I think the other one, you have to caveat it so much because it's not in the security tab and it's kind of a different workflow and different screens. Like the coverage fuzzing is solid. I think this diagram gets the concept across. Mm-hmm. And hopefully entices them to let's talk after the conference kind of thing.
Yep. Okay. Well, hopefully the Q&A is easy. We'll see. That's the part that scares me. They ask too many questions.
I'm sure you're going to do just fine, Cindy. You'll do great.
Well, thank you very much for doing this. I appreciate it. I thought about punting to see if you wanted to take it, but I thought I really need to learn this. So this is the force function to make me make me learn it.
If you've not seen this document in a while, this fuzz testing FAQ that we did a while back, this might be worth a read for some of the sorts of questions you'll get. We originally targeted to salespeople, so some of it's more like positioning sales, but there might be some technical bits in there that could come up.
Okay, that's helpful. Thank you. I've forgotten about that.
When is the presentation? I'll do some other thinking if I can think of any other questions you might get.
So I've got to record it today, but the
Oh, okay.
yeah, but the session is the 20th. It's Tuesday, next Tuesday. So the Q&A with the live Q&A is next Tuesday.
Got it. I mean, if it'd be helpful, I'm happy to, block some time off and sit in the chat room
Yeah,
to help with that.
that might be good, just as my savior.
To back up. Yeah.
I'll ask Joe to send you. He's using some weird meeting thing that I've never encountered before, but it was super simple. But he'll probably have to send you a link for that.
Okay.
Yeah. Okay, cool. Well, thank you very much. What I'll do is after I record it, I'll send it to you, and so that you know what what I said for
What we're covering.
Yeah,
Yeah,
exactly. All right. Well, hey, thank you again. I really, really appreciate your help.
Yeah, happy to